Alright, so as you get more familiar with trigonometric functions, you're going to start to see the patterns here, and this is a question in which you're going to use trigonometric substitution. You got to remember that always you need to keep the trigonometric identities in mind. So if you start with the fact that sine squared x, or maybe I'll use theta plus cosine squared theta equal to 1, that turns out to make cosine squared theta equals 1 minus sine squared of theta. So this is something that very much resembles this. Yes. So if you were to multiply both sides of this by 16 to make it even closer, right? And finally, you could write 16 minus 4 sine theta squared. So I have 16 minus something squared equals to this, which could be easily taken the square root of, right? So this 1/2 in here, which corresponds to a square root, could be easily resolved. So this is the trig substitution we want to make. We wish this were x, so we're going to make it happen. We're going to make, so this is something, just as a reminder, you don't have to write any of this, but just a way to think about what you need to do. In fact, the only thing you need to write when you're solving this kind of problem is what is the substitution you're making. So you're making x equal to the 4 sine of theta, where theta is some variable. So then the x is 4 times the derivative of sine is cosine theta d theta. So we're going to make that substitution and hope for the best, because we know that the denominator is going to work out well because of this, right? So I'll start that way. This is 1 over. So like we just did, 16 minus x squared is 16 cosine theta squared. 16 cosine squared theta. And instead of doing a 3 over 2, I'm going to write a square root, because that's the 1 over 2, and then cubed, because that's the 3 on top. And then the dx I can rewrite as 4 cosine theta d theta. Right. So immediately things become a little more amenable, because I can take the square root of 16, which is 4, and then the square root of the cosine, which is just cosine. We're assuming that the cosine is positive, and where it isn't, the expression is going to hold as well. Cubed, and that's at the bottom of the fraction. 4 cosine theta d theta. Pretty cool, right? So I can now write this as, okay, whatever 4 cubed is, 64, right? Cosine cubed theta times 4 cosine theta d theta. 64 and 4 can be canceled into a 16 at the bottom. I'll pull this out, 1 over 16. Cosine and cosine cubed can be canceled into a 1 over cosine squared theta d theta. This can also seem a bit overwhelming if you're not sure about what's going on. It could be a little confusing. Oh my god, what do I do, right? But if you take a second to see, I'll give you a second, you're going to see they could rewrite this as the secant squared of theta, right? Because the secant is 1 over cosine. And that's great, because we know that the antiderivative of secant squared is the tangent. The derivative of tangent is secant squared, so the antiderivative of secant squared is tangent. So we have solved our integral in terms of theta. Just got to remember how to go back into x, right? So what is the tangent of theta in terms of x? So go back to the substitution I chose to use. I said x was 4 sine theta, so that means that the sine of theta is x over 4. If you remember, the sine is the opposite side over the hypotenuse on a right triangle. You can make a quick sketch of your angle theta, and then the opposite side being x, right, the top of the fraction, and the hypotenuse being 4 at the bottom of the fraction. If I call this y, which is the only unknown I have, I can use the Pythagorean theorem to say that x squared plus y squared equal to 4 squared, so 16. So y squared is 16 minus x squared, and so y equal to the square root of 16 minus x squared. So I know y as well in terms of x. And finally, to finish things up, if I remember back to my original calculation here, that the tangent is the opposite over the adjacent, this is x over y, but I do know y. X is x, y is root 16 minus x squared. So my answer could be written in a very neat way as x over 16 root 16 minus x squared plus c. So that is a very cool example and not very hard example of trig substitution. It would be, like I mentioned before, very easy to change this into a situation where you'd have to use secant or tangent as your substitution. So make sure you practice those substitutions as well.